Okay, so I want to go over the quiz problem, one of the quiz problems that we had the other day, where we had three collinear points, and we wanted to determine if we can find how we would find a plane that had three collinear points, right? So we're given this, and we're saying, all right, you have three collinear points. Now, how do you find a plane that contains these 3 points? All right, so we see here the 3 points, they're collinear. All right, so a lot of you, I shouldn't say a lot, some of you said, all right, well, we can take the cross product, we can find the vector, let's say from A to B, right, and then from A to C, and we take the cross product there, and then we find our normal vector. Right now, I was hoping that you would catch that there is a bit of a problem when we have collinear points, right? If I do take, let's say I call these U and V, right? If I do take the cross product of U and V, right here at the bottom of my screen, we notice that we have a bit of an issue. That this gives us the zero vector. So we don't have a normal vector that we can create our plane equation, right? So is that to say that there is no plane that we can find that? Well, not quite, right? I'd have to take a different approach. So let me delete this here. All right, so one approach that I would take, right, when I thought of this problem, I said, all right, why don't I find a point that is not on the line, right? Okay, doesn't matter which one, just pick a point not on the line, and then I can create a vector from A to D. Okay, and now I have two vectors here where I can find the normal vector between those, right? And that vector turns out here to be this vector A. All right. Okay, so as you can see there, we have, all right, so now I found that normal vector, all right, which is negative 2, 1, 1, and I can create the equation the way I would, the normal vector being the coefficients of the x, the y, and the z, and then a point 1, 2, 3 being on there. And now I found my equation of the plane, give it three collinear points, right? So the 3 points in themselves are not enough information to determine a plane equation, right? We need one extra piece of information that we can get. Right? And I'll graph the line on there again so we could see that that does in fact live on that plane. All right. And the second part of this was, is this plane unique? Well, there was nothing unique of this point B, right, that I chose. It could have been any other point. So this plane is not unique, right? Because I could choose another point and do the same process, right? Find the vector from A to that point, construct the normal vector, construct my plane equation. And then we could see here, here's an example of two planes, right, that contain that line. But really we can have an infinite number of these planes, right? If we only have three collinear points, I can construct any number of planes that contain that line. Thank you.